Now let's figure out what the derivative of that function is. Alright, now we want to find the derivative of y equals to the sine inverse of tangent of e to power x. Good. Okay, so I've written down some basic tools here, which you just gotten from the chain rule. Good. So if you know how to differentiate each of these functions, then you will know how to differentiate the whole of that. Whenever we have to differentiate sine inverse of something, okay, as I've spelled out here, of something. Now this something is just a box, okay? That box contains something in terms of x. If you have to differentiate sine inverse of some function of x, okay, that box can contain some function of x, all right? Differentiating that with respect to x, we are going to have 1 over the square root of 1 minus that box. You square that, then you multiply it with the derivative of that box with respect to x. Well, this fraction here is just from the derivative of sine inverse of x, which we've treated in our previous videos. Okay, so you just take out the derivative of inverse trigonometric function. I gave you a table which consisted of the derivative of sine inverse, cosine inverse, and other inverse trigonometric functions. Good. Okay, so the second tool here is that the derivative of tangent of something with respect to x. So this something here is just a box that contains some function of x, okay, will be, now we have secant squared of that box, okay. That is just from the fact that if we differentiate tangent of, let's say, tangent of x with respect to x, okay, the result is going to give us secant squared x. And by chain rule, if we have tangent of functions of x, okay, we differentiate the tangent function, we get secant squared, okay, of that thing, and we multiply it with the derivative of the inside, which is the derivative of this inside. Good. Okay, so we'll be applying the two rules in solving this, in finding the derivative of that function. So let me put it down for you that for the first tool, okay, we have sine inverse of something. The whole thing here can be replaced by this box, okay? So we are just going to be looking at it and be doing it immediately or at the same time. So that will mean that the y, the x will be, so let's see what this is. Well, the first function, by going like this, we encounter is sine inverse, okay? The derivative of sine inverse of that something with respect to x is going to be 1 over the square root of, okay, 1 minus this box, okay? So if this is sine inverse of a box, the derivative will be that, then this box squared. So this box here, what is it in this function or in this question? It is tangent of e to power x, right? And then we square that. So this has been squared. So let me just square this, okay? So this is from the function. And then we are going to multiply this with the derivative with respect to x of what we just squared here. Okay, this thing that was here, we're going to multiply it with the derivative of that thing. So I'm going to put this down as the derivative with respect to x of, what did we just square? We squared tangent of e to power x. So I put this down as tangent of e to power x, and then you square this, right? You know, this is tangent of e to power x, so there is no need for the square. So the derivative with respect to x of tangent of something will be secant squared of that thing times the derivative of that inside, okay? So we differentiate the outside function. The derivative of secant of tangent will give us secant squared, okay, of something, that is e to power x. And then we multiply it with the derivative of that e to power x. Now, if you differentiate e to power x with respect to x, you will just get e to power x, okay? That is what we get from the derivative of the exponential function or the natural exponential function. The derivative of e to power x will just give us e to power x. So this right here is the derivative of tangent of e to power x. You differentiate the tangent, you get secant squared of e to power x, and then you multiply it with the derivative of e to power x, which is just it here. So I multiply it with that. So we are going to replace this with that, okay? That is after we're done differentiating. So this will now give us, well, since the derivative is this one, I'm going to multiply it with that fraction. That means I'm going to put it at the top. That would mean secant squared of e to power x, okay, times e to power x, which I can multiply it to the back of that. Okay, then we divide that with this square root function, square root of 1 minus tangent of, well, since the tangent of e to power x has been squared, so I can put this down as the square of e to power x. Good. Okay, let's see, can we do some factoring here? Well, This right here is a nice place to stop and call this the derivative of the function which we were given to be e to power x secant squared of e to power x divided by the square root of that. Okay, so this right here is the derivative. This right here is the derivative of that function. All right, anyhow you want to put it.